Scientists are investigating whether we are living in a simulation. This video explores the science and math underlying the simulation hypothesis. We also investigate how much computer power is required to simulate a world. Would we need to construct a structure around the sun to capture all of the sun's energy in order to power such a computer? Is humanity being simulated as two-dimensional beings to save computer power before being projected in 3 dimensions? And could we construct a simulation for humanity that permits us to travel further into outer space? If you believe simulations are conceivable, then we are almost certainly in one. For centuries, people have questioned, what is the difference between truth and illusion? From Plato's cave metaphor in the West to Zhang Zhao's butterfly dream in the East. Plato, who lived between 428 and 348 BC, narrates the story of humans who are imprisoned in a cave. They grow up only seeing other people's shadows on a wall. The shadows are the real world for them. One of the cave inhabitants is taken outdoors one day. He returns to the cave to release the others after noticing how much more real the outside world is than the one in the cave. However, he is now unable to see in the dark. The individuals inside the cave believe the outside world is unsafe and refuse to leave. People who believe that knowledge comes from what we see and hear in the world are represented by the cave. According to Plato, true knowledge is derived from philosophical reasoning. Zhang Zhao, a Chinese philosopher who lived in the 4th century BC, had a dream in which he transformed into a butterfly. The butterfly had no idea he was Zhang Zhao until he awoke and discovered he was Shuangzi. But how can he be sure he isn't a butterfly imagining he is a person, given that both dreaming and waking feel real? How can we tell which is correct? Let's fast forward to 1977. Philip Kindred, who wrote the stories for Blade Runner and Minority Report, contended that we live in a computer-programmed world and that the only signs we have to it are when some variable is adjusted and some change in reality occurs. For example, when we feel the overwhelming impression that we are living in the present as if it were déjà vu. Elon Musk is another person who calls our reality into question, using video game development as an example of why we live in a simulation. Elon believes that we are certainly on a path to having video games that are indistinguishable from reality, that these games will be playable on any platform or computer, and that there will likely be billions of such devices. Elon Musk is curious about the levels above us, saying that the simulation is most likely taking place in a dull environment, because a video game or a film is a condensed version of what is most exciting about life. If we're in a simulation, most certainly, it's really uninteresting outside of the simulation, and the more simulations you go through, the more exciting it becomes. So, how likely is it that we are living in a simulation? Let's look at the physics and math that underpins the theories. Dr. Nick Bostrom, who works on existential risk at the University of Oxford and is supported by Elon Musk, developed the underlying theory of the simulation argument. He offers 3 scenarios. 1, before building a replica of another universe, the human species will become extinct. 2, advanced civilizations capable of making simulations are not interested in simulating their evolutionary history or a variant of it. 3, the probability that we are living in a simulation is close to 1, as we nearly definitely are. According to Dr. Bostrom, because so little is known, we must presume that each has an equal chance for the time being. Elon Musk strongly advises everyone to read Dr. Nick Bostrom's book Superintelligence, Paths, Dangers, and Strategies. If we can develop a simulation, the chances of us being in one grow dramatically. Let's investigate why. When would we be able to develop a simulation? To figure this out, we only need to look at video games and estimate how soon we might be playing and living in virtual worlds that people can't tell apart from the real ones. Elon Musk claims that we have progressed from playing Pong, which is 2 blocks and a dot, to today's hyper-realistic games with millions of participants in just the last 50 years. He was on to say that even if the rate of video game improvement slows by 1,000% from where it is now, picture being 10,000 years in the future and having simulations that are nothing on that evolutionary scale. However, humanity will reach a stage sooner than that when the growth of technology becomes unmanageable, at which point human society will transform in unpredictable ways. We will be able to make such strong video game simulations that the artificial intelligence living within them will believe is their reality. In addition, artificial intelligence would construct games and virtual worlds with numerous levels of simulations. If only one of the million universes is the real world, the base reality, the probability that we are in the base reality is 1 in a million. So, if humans can create a simulation, the likelihood that we are in one grows. Elon Musk claims that the chances of us being in the basic reality are 1 in billions. Astronomer Dr. David Kipping has narrowed it down to 2 options. There are either no simulations or multiple simulated realities and one base reality. When there is no information to determine the possibility of anything being true, all possibilities are regarded equally likely. This is referred to as the principle of indifference. So, in this scenario, there is a 50% chance that there are no simulations and a 50% chance that there are. Even if number 2 is correct, that there are many simulations and one base reality, we could still be in the base reality and the first civilization to develop a simulation. This suggests that the likelihood of our living in the real world, the basic reality, has increased slightly. People like Elon Musk believe and forecast that we will one day be able to create simulations based on the development of video games. If we develop a simulation with conscious beings, the numbers will flip, and most of the arguments against us living in a simulation will collapse, and we'll almost surely be living in one ourselves. The scientists working on proving if we are in a simulation will be up next. The reasons why humans are not in the simulation, as well as the costs of developing a computer strong enough to run a simulation of the universe. Is it feasible to determine whether we are in a simulation? Work is being done to determine whether the simulation hypothesis is correct. Here are 3 methods that scientists are using to determine whether we are living in a simulation. The tests are based on the assumption that the simulation we are living in is run on a computer with limited computing capability, similar to a conventional computer, and that there may be some subtle faults in the simulation, similar to a video game. If we can detect these, it could indicate that we are living in a simulation. Thomas Campbell, a NASA engineer, and his colleagues are attempting to determine whether the simulation is simply rendering what humans can see. As in video games today, the simulation would not model everything at once to save computational resources. It is the technological manifestation of the philosophical concept known as solipsism. Thomas Campbell and colleagues devised a quantum physics experiment, one that employs a series of mirrors, lasers, and slits. They believe that if the cosmos is a simulation that only simulates what we see, then light should act abnormally and clearly indicate that we are in a simulation. Another challenge arises from the fact that the simulation may accrue faults over time as it runs. The simulators would rectify the faults by changing natural laws. However, no drift in physical constants has been seen over several decades. Perhaps our data are insufficiently precise, or the changes occur over long periods of time outside humanity's history. Silas Bean, a nuclear physicist at the University of Washington, is doing another scientific experiment to determine whether we are living in a simulation. He suggests that we might be able to discover the limiting resolution at which the universe is displayed. Spacetime is a mathematical model that combines the 3 spatial dimensions of length, width, and depth with the time dimension. When physicists simulate little bits of spacetime, they divide the cosmos into a grid-like lattice and model it one at a time. Silas Bean and his colleagues consider cosmic rays to be visible light. He claims that if the simulation is split down into a grid, the energies of these high-energy cosmic rays will vary in different directions. So if we can see this, we can conclude that we are in a simulation. The researchers will now investigate what occurs when real-world cosmic rays strike their apparatus. Cosmic rays, on the other hand, only strike a square kilometer of Earth once every 100 years. As a result, this will take some time to prove. Some feel we are in a simulation, but others contend that this is not the case. William Poundstone, author of the book The Doomsday Calculation, highlights a potential flaw in the simulation argument. When we create books, films, or video games, they are often created within a few hundred years of the present. According to William, a simulation would be close in time to the simulator's world. In this situation, our simulation should use widespread simulation technologies and take place in the future. We would be more of an ancient culture without this technology, making us an unusual candidate for a simulation. Others, however, counter that this assumes what an advanced culture would do with simulation technology that may have very different preferences than ours, and there is no evidence that this cosmos was designed specifically for us. We could simply be objects and consequences of a simulation created to evaluate a hypothetical scenario. Sean Carroll, a cosmologist, makes another case. If civilizations can produce simulations, they will be able to generate additional simulations. There might be thousands of layers, and the more simulations there are, the deeper you go. As a result, the deepest layer has the greatest number of simulations and simulated persons. Each simulation, however, must be less complex than the universe above it, because the computer's power decreases with each subsequent layer built, because the level above must compute it alongside the simulations below. As a result, there is a floor limit on how deep you can go. Because there are no more resources available, the society in its lowest stage will be unable to produce simulations. If the simulation hypothesis is right and there are numerous levels, we are undoubtedly at the lowest level and may be unable to generate simulations. How can we know if a universe could ever be simulated if we can't make one? This is referred to as the Carroll's contradiction. Many argue that this is not a contradiction and that we can be both in a simulation and unable to mimic our own reality. Let's look into the future. Silas Beam, a nuclear physicist who is attempting to determine whether we are living in a simulation, predicts that we will be able to simulate the entire cosmos within 500 years. In actuality, we'll probably keep doing what we've been doing with video games, simulating only the areas of the cosmos that the players are now looking at. This means that depending on the number of simulated humans in the universe, we could simulate a full universe considerably faster. According to Nick Bostrom, experts estimate that the number of operations per second required to mimic a human brain is between 10 to the power of 14 and 10 to the power of 17, with the additional processing power required to simulate the surroundings. Computers today can perform more than 10 to the power of 9 operations per second. To conserve processing power, everything might be simulated in 2D, making you a 2D person and then projecting everything in 3D, similar to 3D movie displays or holograms. According to Bostrom, the expense of creating an accurate simulation of all of human history is between 10 to the power of 33 and 10 to the power of 36 operations per second. In his study by Matryoshka Brains, R.J. Bradbury believes that a computer the size of a big planet could process 10 to the power of 42 operations per second. A Dyson sphere would be necessary to power such a computer, which is a framework created around a star like our sun to absorb all of its radiation. Would such a powerful computer be able to convert humanity's consciousness into a simulation that would allow us to travel further into space? That's all for now, guys. If you want to learn more about this type of content, consider subscribing to my channel. I'll see you at the next one.